In this video, I am going to explain the distributive laws of Boolean algebra. There are two distributive laws. The first one is A into B or C is equivalent to A and B or A and C. The second one states that A or B and C is equivalent or identical to A or B and A or C. The first one is quite straightforward to explain. The second one, we will have to do a mathematical proof using Boolean expression to explain it. So let's focus on the first one. So here we are saying that we have A and B or C. Very similar to what we do in our traditional linear mathematics, we can expand this bracket by ending this A with B and then ending it with C. Therefore, this will become A and B or A and C. That is the first law of the distributive from the distributive laws. For the second one, we have to do a proof using Boolean expressions. Therefore, here I am going to prove this law. Now, whenever we have to do a proof, we always start from one of the sides. We use the laws of Boolean algebra and we try to arrive at the other side. In this case, it makes sense that we start from the right-hand side because it is more complex and therefore we have more room to work. So I'm going to start the proof by doing this. Right-hand side is identical to, and I'm going to copy this, A or B into A or C. Now, using the expansion technique that I have explained before here, we are going to expand this by first ending this A with that A there and with that C there in order to get A and A or A and C. And then I am going to do the same with this. So this will end with that one and with that one. So now we will get or B and A, which I'm going to write in alphabetical order immediately as A and B, or B and C. That is the first step. To do this step, we have used one of these distributive laws, the first one. So I am going to write the law that I have used so that whoever is looking at this proof will know that each step makes sense. So we use the distributive. Now, here we have A, and we know that using the tautology laws that I have explained in my previous video, when we have A and A, it gives us an A. Therefore, this one can be reduced to A or A and C or A and B or B and C using the tautology law. When we have an expression with many terms, like this, it might make sense to try and group terms. Therefore, we find something common and we group it. And if we have a look at this, we have A here, and A here. Therefore, if we take out A as a common input, so A into A goes 1, or A into AC goes C, or A into AB goes B, or B and C. And here we have used the tautology, we have used the distributive law, because like we did here, okay, we are expanding or creating brackets. Now, if we focus on this bracket, and we can also sketch here what we have. We basically have an OR gate, and in this OR gate we have 3 inputs, 1, C, and B. We know that whenever we have an OR gate, that there is a 1 going through it, the output is always going to be 1, irrelevant and irrespective of what the other inputs are. And this is also another tautology law that I have explained earlier on, which is this one, 1 or A gives us a 1. Therefore, we can say that here we have A and 1, and this 1 was obtained by simplifying that bracket, or B and C. And the law that we have used here is the tautology. So now we can get rid of this 1, because with tautology we know that A and 1 is equivalent to A, as you can see here. Therefore, we can write this as A or B and C using the tautology law. Now A or B and C is equivalent to the left-hand side, so it is identical to the left-hand side as required to prove. Therefore, our proof is now completed.